Now let's focus our attention on the Vsftpd server. Vsftpd is an acronym for Very Secure FTPD, or File Transfer Protocol Daemon. And it features FTPD, which means file transfers using the standard file transfer protocol on the internet. It also features a number of security items such as change root, which can force your users into a jail, so change root jail, as well as anonymous and a local user auth, amongst many other features. It's included with Red Hat Enterprise Linux, so let's set up our first task, and that is to install it. It's also protected by SE Linux. So on the remote system, we'll rpm query all grep vsftpd. This will tell us momentarily if it's installed, and if not, we'll find it in the repository, then use yum to install it. So as you can see, it doesn't exist on the remote system. It was not installed, unless during installation we indicated that we'd like to have the FTP server available. So Control F Vsftpd in the web browser will help us to search for the package. There it is, version 2.05. So again, rather than RPMing the HTTP URI, we'll simply on the remote system execute yum install Vsftpd. This will find the appropriate package and respond yes to whatever prompts pop up. And now when we rerun rpm query all, we'll see that it's installed. Once it comes back, we'll enumerate the list of embedded items. Let's reset the buffer, then rpm query list Vsftpd to see what's included. And it includes, as you can see, tons of documentation. But starting from the top, there's a log rotate entry, since FTP servers tend to be busy. We'll log lots of information per session regarding files transferred in and out of the system. There's a PAN file which controls authentication, since again, the service allows you to authenticate not only as anonymous, but as well as local users. So rather than implementing its own auth facilities as older FTP daemons did, Vsftpd has a plugin or a hook to PAM, or pluggable authentication modules. It has its own service entry in init.d. It has an etc directory called Vsftpd, with some files that are important if you want to filter access, FTP users, user_list. There's a primary configuration file, vsftpd.conf, a migration configuration file, the main daemon itself in user sbin vsftpd, tons of documentation, a space beneath anonymous, or before anonymous, beneath var ftp pub, etc. Let's navigate into etc. Again, this is where you'll find the primary config file beneath Vsftpd, amongst others. The FTP users file that you see here contains a list of users who should not be allowed to log on to the system using FTP. By default, the list includes users like root and other daemon users. Again, they should not be granted access via FTP, because it is a clear text protocol, and if their credentials are intercepted by someone who has access to the network or networks in between you, the client, and the server, or between your client and your server, then they'll be able to compromise your system. So it is not a good idea to permit root or daemon level access via a clear text protocol such as FTP, which is why this file is maintained. There's also a user_list file, which serves a similar function to FTP users in the event that the user list deny variable is used, and it's self-explanatory. It too includes the same list of users you find in FTP users. Again, this file, users or user_list, pertains to whether or not you use the user list directive within the primary Vsftpd configuration file. There is the migration script, which is a shell base script, vsftpd_conf_migrate.shell, and it's used to migrate older versions of vsftpd.conf to the new version. Again, the version that we currently have installed, as you see in the background, is 2.05, but this migration script will move items for 2.01 to the new config file directory structure on the Red Hat Enterprise 5, which is beneath Vsftpd as opposed to just beneath etc. And again, the primary config file is vsftpd.conf. It includes all of the directives that the server will honor when it starts, such as the default allow anonymous, as well as whether or not to allow local users. This is defaulted to yes, so it allows anonymous and local users. Whether or not to permit writing, the umask, so when a file is written or a directory is written, what will be the default set of permissions, 777-022, will apply to directories, and one off for files for 644, as well as other directives, whether or not there's a log file, a directory message, if there's a hidden file per directory to be displayed to the user, whether or not connections are to be from port 20 when the FTP data protocol is in use, and many, many other directives. Now again, there's no need to memorize, as we'd like to say, the directives. If you RPM query list vsftpd, you will see that there is a man page for the configuration file independent of the daemon itself. The daemon's man page includes startup options. However, the vsftpd.conf man page includes directives that govern how the system is to bind to the network, as well as accept users, as well as other options, whether or not SSL is enabled, etc. A through Z, the directives are listed when you man the vsftpd.conf file. Vsftpd also supports rate limiting. We should list that as another feature. That is the ability to dictate the speed at which users may upload as well as download items from the FTP server, and you can tie those directives to anonymous independent of local users. So, for example, you can force anonymous users to one transfer rate and local users to another transfer rate. Now, before we delve too much into the directives, how do we actually start Vsftpd? Well, as mentioned, in etc, inet, or init.d that is, there's a vsftpd entrance, which means we can use service space vsftpd start. So we've installed it, and we did so using yum y install vsftpd. Now, next task is to start the server using service vsftpd start, and then we'll confirm using netstat ntlp grep21, since FTP listens to port 21 by default. Let's give this a start from the shell, and we'll echo the exit status to ensure service executed correctly. Then execute netstat ntlp grep21, where we see that Vsftpd is listening to port 21. So the version of Vsftpd included with Red Hat Enterprise 5X runs outside of zinad. It is started explicitly from etc initd. And if you want this service to start up every time the system boots, we'll again check the check config status. It's off in all run levels, so you can optionally indicate the run level that you'd like, or just check config Vsftpd on for all multi-user run levels. So now this service will be started whenever the system comes up. Now how do we connect to the server? Where will we be placed? What will happen? So our next task after starting the server and confirming that it's running, we'll just list as configure service to start when system boots into multi-user run level. And that's simple. Check config Vsftpd on does the trick. And we can follow that up with we did follow it up with check config list Vsftpd. Now the next step for us is to connect to the FTPD daemon. There are myriad ways to do so, but we'll begin by using the web browser. So use web browser, which defaults to anonymous. This will test our anonymous connectivity to the server. So with that said, let's launch the browser, and in a separate shell, separate tab that is, we'll connect to 192.168.75.199 using FTP. And we drop the protocol, and this will attempt to connect us as anonymous. And there you see the pub directory beneath var FTP. Let's just confirm it. We'll navigate on the remote system to var FTP. This is the anonymous space. And there we see pub. Let's see what's currently in pub. Nothing. So when we navigate to pub, we'll see nothing. What if we create a file using sequence? So sequence 1 million test or 1million.txt. This will create a file with permissions that are read-writable by root and readable by root and everyone else. The last 3 bits indicates everyone else. Let's refresh the web browser window to see if we were able to see the file, and indeed we are. We click on it, it's a text file, which means we will be able to view the contents of the file within the web browser. It takes a little while because it's roughly 6.5 megabytes, and the browser is designed to pull usually small items, but nonetheless eventually it will be returned, or we can kill the process altogether using stop. Text items are automatically displayed by the web browser, so don't expect a pop-up concerning saving the file to occur unless you change the suffix or a right button, save link as, and then indicate that the file should be downloaded. So while this cooks, how about we attempt to connect using a standard FTP client, FTP. So step B for us will be use standard FTP client. As anonymous, just to see how it works from the shell. So let's open an instance here, and we'll do so from our local system. We don't need to be root, we'll drop out of root's shell, and then FTP as anonymous to the IP address. Again, if the host name is configured, it will work as well. And here FTP is throwing an error. Let's try it without username. We'll quit and just try to connect to the IP address. Now it takes it, so it didn't take the user at. So we'll have to indicate anonymous and then indicate a password. And now it's allowed us in, and we should be able to ls and see the pub directory. And there's the file. If we want to get it, we can execute mget 1mil star, and this will download it and return the transfer rate, and we have it available. An exclamation ls will show that the file has been downloaded, but we have so many instances of 1 million that it's hard to tell. Exclamation lsltr would reveal the item at the bottom of the list, and an ls on the server returns what's there. Now how about trying to upload an item to the server? Let's see, we have 1million.text.tar.gz. Let's try to input it, and we'll indicate yes, permission denied. Now why are permissions denied? Well, if you take a look at etc vsftpd vsftpd.conf, you'll see exactly why. Anonymous access is enabled, local access is enabled, write access is enabled, but the anonymous user has its own write directive. And because it's disabled, the user is unable to write to the server. For example, here it is. Anonymous upload enabled equals yes, but it's commented. Anonymous make directory write enabled equals yes, but it's commented. So the effective permission is that it is disabled for the user. They're unable to write changes. The general write enabled will apply to the local users. So above we saw write enabled equals yes. This will permit writes for local users, will not permit writes for anonymous users if the anonymous upload enabled is set to commented or no. So that's why the user is unable to upload items as anonymous. Now how about connecting as a privileged user? Let's do so from the shell. We'll drop our permissions and then connect again, this time as the user Linux CBT, which it defaults to, like SSH would. Then we'll indicate Linux CBT's password, see if it lets us in. It's going to check it. If it doesn't like it, that means we've typed it in incorrectly. Here, let's try it again. And we timed out, so we'll connect again. And this time it throws an error after having specified the correct password, and that is it cannot change to the user's home directory again. This is SE Linux stepping in the way, so let's quit and examine the contents of the log file, via log messages that is. It'll explain what's going on. There it says SE Linux is preventing the user. Use SE alert with the following code to get more information. So we'll copy it, clear screen, reset the buffer, then paste, and then let's see what the suggestion is to get around this SE Linux problem. And if we scroll up, there is a set SE bool command which will do the trick. So we need to turn on the FTP home directory booling, which allows FTP to service users from their home directories within an SE Linux context. Let's go ahead and execute this. Let's just include this on the list. The set SE bool permits users access to their home directory. This will make the change. Then we'll need to restart the Vsftpd instance. For changes to take effect. And then try to connect again as a normal user, meaning a non-anonymous user. And now when we re-execute FTP, which we'll find momentarily, and it's not showing up, it's in this window. And now we're in the user's home directory on the remote system. The remote system has a new user Linux CBT, so there are no files. If we connect and create a file, we'll see it. We'll call it linuxcbt.txt. And then in the FTP window, we'll ls, and there's the file. We can get it. This will pull it to our local system, returning a transfer rate. ls linuxcbt.txt will confirm that it was transferred. We may also put files to the remote system if we'd like. The permissions are in place. But one problem with this implementation is that it isn't change root jailed, which means we can actually navigate to the root of the file system, which is generally not desirable. Here's the whole root of the file system, logged in as a non-privileged user. Obviously, we won't be able to make changes to entries that we don't own or have permissions to via group membership, but nonetheless, it's never good to be able to explore the whole root of the file system using a clear text-based protocol such as FTP. So with that said, we should update the Vsftpd configuration. So the fifth option, or the fifth task, is to change root jail local users and disable anonymous access, just to tighten up the security a bit. So with that said, on the remote system as root, we'll modify the primary config file, vsftpd.conf. We'll set anonymous enable set to no, or comment it out. Either or will do. We'll look for our change root option. There's a way to change root list as well. For example, you could indicate a list of users who should be change rooted, or indicate that all users should be change rooted. Now that option, although it's not specified in this document, can be obtained by manning vsftpd.conf and just keep searching through the directives for the change root option. This is the list option we just saw, but here's the option, change root _ local _ user. The default is set to no, which is why we're able to navigate to the root of the file system. That's vsftpd.conf again. You can paste it anywhere in a document, such as at the end, change root local user equals yes, and we'll just indicate jails users into their home directories. We'll save the changes and again restart the daemon. So we've set the directive change root local user equals yes. This jails users, and then we'll restart again the service and test connectivity. Now on a very busy system you can flirt with reloading versus restarting the service in the event that you'd like to see directives take effect without disrupting connected users. So with that said, let's restart the service, which should be in our history, and then again attempt to connect to the jailed environment. So from the local system, let's quit the FTP session and then reconnect. And now when we type pwd, you'll see we appear to be at the root file system, but we're really in the user's home directory, and if we change directory /, we're still in our home directory. So we've improved the security of the system. Now how about testing anonymous? So service start, test connectivity as anonymous and non-anonymous users. So we've tested non-anonymous. Let's confirm that anonymous is unable to connect. And as you can see, this is taking a while to make its decision, but that doesn't let us in. Instead of returning anonymous disabled or anonymous access not permitted, it simply tells us login failed, and it logs it in varlog messages, or optionally in varlog vsftpd.log if you've indicated as such in the configuration file. And in order to do so, you'll just ensure that the extra log setting is set to yes, which defaults to varlog vsftpd.log. From the shell of the remote system, we'll simply modify vsftpd.conf and find the exfr log session, or section that is. It's enabled, and it defaults to varlog vsftpd.log, but you can uncomment it just to be sure that it will log to that file. Save the changes, restart. This will restart it, and it'll maintain items distinctly. And also recall, there is a log rotate entry as a result of installing this daemon, and it will rotate vsftpd.log when it finds it, using the default settings inherited from etc.logrotate.conf, since there are no settings defined in vsftpd.log. This tells us it'll do so weekly and keep it, or rotate 4 times, keeping it for a month. Now for the older log entries, you'll find them in the x4log file. So less varlog x4log will include the puts and gets, and there they are, and who the user connected as, so on and so forth. So for example, when we connected from Firefox, it's supplied as a password mozilla@example.com. However, otherwise we see connectivity for other sessions, like CBT and so on. So that said, we've connected using vsftpd. Remember, it supports all sorts of features, including transfer rate limits, and then vsftpd.conf will reveal those directives, which allows you to restrict the speed at which users, either anonymous or otherwise, are able to upload and download to the server. You may also change root based on a list. You may also allow change mods of files and or directories. You may chown uploads, meaning change ownership. So a user may upload a file, let's say as Linux CBT, but you may want the file to be saved under someone else's credentials. That's quite possible using vsftpd. You can set up a list of email addresses, offensive email addresses to disable in the event that you publish an anonymous server and users are abusing it. If the directory messages are enabled, if there's a hidden file in a directory that a user enters, that hidden file will be processed and returned. If it's a hidden file .message, will be processed and returned to the user when the user enters that directory. Even a user's default home directory. So for example, let's open a separate shell here. We'll scroll through this first and come back to that in a moment. There's dual log support. You can log to x4log and varlog vsftpd.log. Tells you the former x4log is in the form of Washington University's FTPD, whereas the latter is in vsftpd's format. Again, SSL support is provided by vsftpd, so if you want to provide an FTP secure server, you can. If listen is enabled, vsftpd runs outside of ZynetD. If it's not set to listen, it can be controlled by ZynetD, the super server. It also supports IPv6, with the default being no. Let's SSH as root to that system, just to have another window open so we can discuss it while we look at the directives. Currently, if we netstat ntl grep21, we'll see that it's listening to IPv4. We know because it's using the address all zeros as opposed to :21. So right now it's not listening to IPv6, but it can listen to IPv6 if you indicate listen_IPv6 equals yes. Let's go ahead and turn that on anyway. We'll nano etc vsftpd vsftpd.conf, and it will just search a document for IP6, and listen is set to yes for IPv4, but listen_IPv6 is set to off, indicated by the comment. So let's go ahead and execute service vsftpd restart. This will cause it to listen to IPv6, and if it doesn't, it gets thrown an error in this particular case. It could be because the IPv6 address threw an error in binding, and a tail of varlog messages will return an error as to why the IPv6 interface failed, which we'll look at momentarily. So let's go ahead and just modify it again to get it started so we can continue what we were doing. We'll nano vsftpd.conf. Let's find IPv6. here it tells us that in order to listen to IP version 4 and IPv6, you must run 2 copies of Vsftpd. And it also mentions right above that you cannot use listen equals yes with listen IPv6 equals yes, which is why we threw an error. So it's not SE Linux, rather the fact that we cannot use both directives. Now it's started, let's netstat.ntl, and if we look for port 21, we now see that it's bound to IPv4 and IPv6. So as a separate task, enable IPv6 listener. We just ensure that this is enable equals yes, and indicate do not use with listen equals yes, which is used for IPv4. But if you wanted to use it independently, the documentation suggests that you run 2 instances of Vsftpd. Now when you listen to IPv6, you can connect using 4. Let's go back to our local system, ftpn, abc123 is the password, and there we're in using IPv4 that is. But if we know the IPv6 address of the server, we can use that address as well to connect. Now let's continue looking through our directives. We can log the FTP protocol, password change rule enable, pass v. This FTP server supports both passive as well as active modes. By default, passive is enabled, but both will be supported or run at the same time and supported sort of simultaneously, in that if the connecting user wants active, the server will switch to active, and if they want or request passive, then passive will work. Whether or not to turn on SSL, the versions of SSL, whether or not to log through syslog and to enable TCP wrappers, meaning the ability to control security to the system, to the FTPD system via TCP wrappers, or etc hosts that allow and deny files. Whether or not write enable should be permitted. X for log, whether or not it's enabled, and it's currently set to yes. And then you've got the numeric options we were talking about earlier, which is the reason why we looked at the documentation to begin with, which includes the transfer rates for the classes of users, including anonymous and non-anonymous. So to control anonymous's transfer rate, you'd use anonymous or a non-max rate, and you'd set it to a value in bytes per second. So for 1,000 bytes per second, use 1,000. A non-max rate, 1,000. But you've also got other numeric options, such as the ability to timeout connections, connect timeout, which defaults to 60 seconds. You can set it to lower or higher to suit your needs. Idle session timeout, if you don't make any changes after having established a connection within 300 seconds or 5 minutes, the connection will terminate. And for non-anonymous users, the local max rate measured in bytes per second will restrict the transfer rate if set. So if you set local max rate equivalent to a low value, then users will be forced to move data at that low value. Let's modify etc vsftpd.conf again, and we'll navigate towards an empty space commented as restrict transfer rate for non-anonymous users by setting local_max_rate equal to a certain number of bytes per second, such as 1,000 bytes per second. Restart the server. Then reconnect from our local system. And then attempt to list the directory's contents and get the file linuxcbt.txt. And this will take forever and a day to transfer the file and then return the transfer rate. Now when we look at LFTP next, you'll see the transfer rate dynamically But the reason why this is not yet complete is because it's transferring at a slow rate. So a seventh feature would be to restrict non-anonymous users' transfer rate. This is a way to control the amount of bandwidth that's dispensed or used by your FTP server. You may have a T connected to the net, or fractional T, or 100 megabits, or what have you, but want to segment or restrict the utilization per connected user. So set local underscore max per rate equal, let's say, 1,000, restricts connections to 1,000 bytes per second, or roughly 1K per second. As indicated in the man page for the configuration file, Vsftpd conf. And again, that's the local transfer rate in bytes per second. So if you set it to 1,000, then that's 1,000 bytes, or 1K per second. And this is again for local authenticated users. You may set a UMask for the local user independent of the anonymous user. Maximum login failure attempts. If the default is 3 and it works with your environment, your security policy, then no need to indicate it, but if it's lower or higher, adjust it accordingly. Maximum number of connections per IP, per source IP. Currently it's by default it's unlimited, but you can indicate whatever suits your environment again. Again, Vsftpd is highly configurable. We could easily spend 2, 3, 4 hours or more focusing on this one application alone. But we've shown you how to set it up, how to circumvent or bypass SE Linux to ensure that users can access their home directories, how to disable anonymous, how to set transfer rates, and to test it by trying to download something which is still downloading, and how to enable various options. But there are many other options such as message files, banner files, you name it, for connecting. It's a highly configurable file transfer protocol daemon server included with Red Hat Enterprise Linux, but not installed by default. And now you know how to set it up and get some basic settings going. Next we'll look at LFTP, which is a file transfer protocol client.